Hello everyone, welcome to this presentation on object-oriented development. My name is Muskan, ID 2410994840, and today I'll be taking you through the key concepts of CIT 223, object-oriented development. Let's begin. Class is like a blueprint. It defines what attributes and behaviors an object will have. Once a class is created, we can make multiple objects from it. Each object is a real-world instance that has its own state and behavior, but follows the rules defined in the class. This is the foundation of object-oriented programming. Encapsulation is a core principle of OOP. It means keeping an object's state private and only exposing it through methods. This prevents unwanted changes to data, makes code more secure, and allows us to make changes internally without affecting other parts of the program. To implement encapsulation, we use accessors and mutators, also known as getters and setters. These methods allow us to read and modify private values safely with validation. In C#, we often use properties with get and set keywords for a clean and readable approach. Loose coupling means classes are independent and don't rely heavily on one another. High cohesion means each class is focused on a single responsibility. Together, they lead to better maintainability, flexibility, and reusable code. The golden rule is, design classes that are highly cohesive and loosely coupled. Control flow defines how the program executes instructions. It includes sequential execution, selection using if or switch statements, and iteration using loops like for and while. Mastering control flow helps us build interactive and dynamic programs. In C#, we use try-catch finally blocks to handle runtime errors gracefully. Instead of crashing, our program can display user-friendly messages and maintain control. Always use specific catch blocks first to make debugging easier. Here are some common C# exceptions. Null reference exception occurs when accessing a null object. Index out of range happens with invalid indexes. We also have divide by zero, invalid cast, stack overflow, and others. Knowing these helps us anticipate and handle problems before they break our program. UML, or Unified Modeling Language, is a visual way to represent object-oriented systems. The class diagram is the most common, showing classes, attributes, methods, and relationships. These diagrams help us design before we code. Good design is an investment. It helps us clarify structure, avoid problems, and reuse components. Without design, we risk messy code, debugging nightmares, and poor scalability. So plan first, code second. Inheritance allows a child class to use properties and behaviors from a parent class. It helps reduce duplication, standardize structure, and simplify updates. The subclass can add or override behavior while reusing the core logic from the superclass. Inheritance has great benefits like code reusability and consistency, but it can also create tight coupling, inherited bugs, and rigid hierarchies. Always use it where it makes sense, when there is a clear ISA relationship. Overloading allows multiple methods with the same name but different parameters in the same class. Overriding is used to change inherited behavior in a subclass. Overloading gives flexibility, while overriding gives customization. Polymorphism means many forms. It allows different objects to respond to the same method in different ways. This leads to flexible, extensible, and loosely coupled code, a key benefit of OOP. Abstract classes are partial blueprints. They can have implementation. Interfaces define contracts without implementation. Use abstract classes when behavior is shared, and interfaces when multiple classes need to follow the same rules. Delegates are type-safe references to methods. They let us pass methods as parameters, power event-driven code, and support callbacks. Think of them as function pointers, but safer and more powerful in C#. Extension methods allow us to add new methods to existing classes without changing their source. Lambda expressions are shorthand anonymous functions, used in delegates, link, and event handlers for cleaner, more functional code. To wrap up, we covered core OOP principles like encapsulation, inheritance, polymorphism, and good design. We also explored powerful C# features like delegates, lambdas, and interfaces. Thank you for your time and attention. I hope this presentation helped make object-oriented development concepts clearer and more practical.